we are doing application, which just means word problems. So things to remember, we're still just using our formula. And the reason we're going to use the formula is because now that we're dealing with real world things, we have lots of decimals and stuff. Now, another thing is, before this day, we've been leaving our answers in like 3 plus or minus the square root of 2 over 4 or something. You know what I mean? Now, if I said, hey, how long is it going to take for whatever, and you answer like that, are you going to be crazy? Yes. Okay. So today we actually get to type them in our calculator and get a decimal. So that makes it easier, even though it's coming from word problems. So knowing that, it says the formula for throwing an object is this. You'll see it's missing pieces. Okay. Where S is the height of the object, so the current height of the object. So that's like if it's only been 1 second, it's here. Okay. While t is seconds, time in seconds, v is your initial velocity, and h is the height the object is thrown for, so the starting point. Okay, so knowing that, it says if a man is 5 foot 9 inches and throws a ball. So think about it, when you throw a ball, is it pretty much from your height? Yeah, you're not like, we're not underhand tossing, okay? So we have to put that in feet. And this is going to be the starting height. So this is your h. However, I can't put feet and inches in my equation. So knowing that, I have to turn my inches into a decimal for feet. And the way you do that is you take the inches divided by 12. And that gives me 0.75. So this becomes a height of 5.75. Now, I will tell you, on your practice, I was nice and the formula is plugged in for you. Okay, and then it says, and a ball thrown at 25 feet per second. Is that my time, my initial velocity, or my current height? Yeah, that's my velocity. So velocity is 25. Okay, how long will the ball be in the air? Well, here's my question. If I tell you to record how long something's in the air, when are you going to stop recording? When it touches the ground. And what is the height when it touches the ground? 0. So I'm looking for when S equals 0. Because remember, S represents the current height. So knowing that, we're going to plug those 3 things in here. So S is 0 equals negative 16 t squared. We don't know t for time because that's literally what it's asking, how long. Okay, plus v is 25 times t plus h, which is 5.75. Now, knowing all of that, the best method to use here is just our quadratic formula. Does it already equal 0?
Yeah.
So I'm just building my skeleton. And what's my A? B?
25.
And C.
5.75.
So I'm going to plug in what I know. Now, I know that because I'm finding the decimal, I could technically type this whole thing in my calculator. However, I don't want to make any mistakes because when you type the whole thing, it's hard to see it. So I still personally like to simplify the 3 pieces. So I know this becomes negative 25 plus or minus the square root of something over 2 times negative 16 is negative 32. And then I'm just going to type my discriminant. So 25 squared minus 4 times negative 16 times 5.75. And I get 993. Now, I don't have to break that down because I'm looking for an actual time. So you're literally just going to type this in your calculator. Alpha y equals enter negative 25 plus the square root of 993 over negative 32. And I get this. So I know that one of my answers, it says round to the nearest tenths place, so negative 0.2. And then if you don't want to type that again, you can hit second enter, highlight the plus sign, and put a minus sign, and I get 1.7 or 1.8. Which one? 1.8. Now, which one of those does not make sense? Yeah, you cannot have negative time. So what's my final answer? 1.8 what? Any questions there? So like I said, you technically could have skipped this step and just typed this whole thing in the calculator, but it's super simple to make mistakes when you're typing that much in your calculator at once. That's why I still like to break it apart. Okay, so if we look at B, it says, at what time will the ball be 10 feet high? So we want to know when the current height of the ball is 10 feet. So S equals 10. So knowing that S is the beginning, so we're just going to set this equation equal to 10. So 10 equals negative 16t squared plus 25t plus 5.75. Am I ready to find A, B, and C? No, what do I need to do first? Yeah, I have to subtract 10 from both sides. Okay, so my A is negative 16, B is 25, and C now is negative 4.25. So I know, what am I doing? I still have negative 25 plus or minus the square root of something over negative 32, but my discriminant changes. To 353. So now I can type it one piece at a time. And I get two answers. Now I know it says to round to the nearest tenths, but we're going to do hundredths to practice both. So what would this be rounded to the nearest tenth? I mean hundredth, sorry. What would the first one be? 1.37. Yeah, 1.37. And what about the bottom one? 1.9 or 1.19 or Jesus, 0.19 or 0.20? 0.19 because 4 is less than 5. This one rounded up because of the 8. Now, do both of those answers make sense? Yeah, think about it. If you're however tall you are and you throw the ball up and it goes up and then back down, is it going to be a height of 10 twice? Yeah, it's going to catch a height of 10 going up and back down. That's why there's two answers. So you're just going to use both. So 0.19 and 1.37 seconds. Okay, this next problem is super gross, so we're not going to go all the way through it because it's the same stuff, but I'm going to hit the key things that you need to know. Yes? The reason it's super gross is because look at the equation. What do you notice? It has a billion decimals, right? We could get rid of the decimals like we did before when you multiply, but it's still big numbers, okay? So, and technically when you're using the quadratic formula, you don't have to get rid of them, so we're just going to talk. So it says, what will the population be in 2012? Let me read this first. So it says, the table shows the population of a country in Africa. The quadratic equation to determine the population in millions of people is this, where P is the population, X equals 0 for the year 1940. So that's telling us that this started in 1940. So if I made like a little third piece, 0 at 1940. So then how many years later is 1960? From 1940? 20. Okay. Does that make sense? So it's how many years from then? So if I'm asking about 2012, well, 2012 minus 1940. That's 72 years later. So if it says what will the population be in 2012, well, I know that x equals 72 in 2012. Can I just plug x into the formula? Yeah, so I have P equals, because I'm solving for population, so I don't have to do the quadratic formula here. I get 0.0019 times 72 squared minus 0.0572 times 72 plus 0.5723. And you get 6.3035. But it says round to the nearest tenth, so what would that be? 6.3 what? What do I label this? This is P for population. And what is population? Million. Now, the next piece says what year was the population? About 1.85 million people. So we would have done 1.85 equals 0.0019x squared and all this, yes? But then you have these ugly decimals you're plugging in. So I'm just going to tell you. If you end up with like 45 point something, it says round to the nearest whole number. So you get x equals 45, and then you get x equals a negative. Well, negative doesn't make sense. But here's my question. This is not my final answer, because it says what year. So if x is 45, how would I find what year that is? Add. So you'd add it to 1940, and what does that equal? So that would be your answer. So we skipped way many steps here because this is super ugly with all the decimals, and I didn't feel like going through it. It's the same thing as number 1 A and B. That's all you would have done, but it just gave you really ugly decimals. So I didn't feel like confusing everybody and stressing y'all out. Okay, so you have a practice. I'm being kind, and I'm letting y'all cross off number 5 to make sure you have time to finish. So you can cross off number 5.